Solve the equation. The square root of the quantity x plus 7 minus the square root of x is equal to 1. Let's begin by isolating one of these radical terms. So I'm going to add the square root of x to both sides. Thus we have the equation the square root of x plus 7 is equal to the square root of x plus 1. Now we wish to square both sides so that we can eliminate a radical here on the left. As we square the square root of x plus 7, that gives x plus 7. On the right-hand side, don't forget to FOIL this out. We have a binomial squared. That's going to take the form of our first term squared, the square root of x, quantity squared, plus 2 times the product of our terms. So 2 times 1 times the square root of x, plus that last value itself squared. So this gives x plus 7 is equal to the square root of x, quantity squared, is equal to x. Our middle term becomes 2 times the square root of x, and we've got a plus 1 there at the end. As a next step, we see that we still have a square root radical in this equation. Let's isolate it and then square both sides again. Subtracting x from both sides eliminates the x. If we subtract 1 from both sides, 7 minus that 1 is 6. So 6 is equal to 2 times the square root of x. Now I'm going to take one more step here and divide both sides by 2 to get 3 is equal to the square root of x. And now let's square both sides again. So 3 squared is equal to the square root of x squared, or 9 is equal to x. Or you might write that x is equal to 9. We have one possible solution. Let's check it in the original equation. That original equation is the square root of x plus 7 minus the square root of x is equal to 1. Substituting 9 in for x, the square root of 9 plus 7 minus the square root of 9, is that equal to 1? So the square root of 16, or 4, minus the square root of 9, 3, is that equal to 1? Yes, it sure is. That is true, and x equal 9 is indeed a solution. Let's summarize that by saying the solution set is the number 9.